Hello everybody. Now I want to talk about speed, velocity, average speed, and position as a function of time graphs. So I've made a little change to my simulation. Now I'm going to be showing a graph. And I wanted to introduce graphs to you guys, and I wanted to talk to you about velocity. So first, let's define what is velocity. Okay, so velocity, what is that? Velocity is a rate of change of position. All right, so that's the definition in words. Rate of change implies how fast something is changing. We know that position, that was the symbol X or Y or Z. That is the location of an object. So one way we could calculate the, let's talk about the symbol first. The symbol for velocity is V with an arrow over it. The arrow over it means vector. So velocity is a quantity where direction does matter. So I say direction does matter, or I would mean, what do I mean by that? Direction is communicated by velocity. If it's not communicating a direction, it's not a velocity. Okay? Just like position, the quantity position has to communicate a direction, meaning which side of the origin are we on. For velocity, the direction means which way is it moving. So because the direction does matter, we call this a vector quantity. Okay, so we're basically categorizing all of these quantities as is it a vector quantity, meaning is the direction communicated by the quantity? Is the direction communicated by that quantity? Or is the direction not communicated, in which case it's a scalar quantity? So V with an arrow over it for velocity is the symbol. And one way to define it is that the velocity is equal to a tiny change in position divided by a tiny change in time. Only if these changes are super, super small. So what we can say better is that an average velocity would be a change in position divided by a change in time. So average velocity is change in position divided by change in time. Now change in position, that's a vector quantity called displacement. So really we're talking about displacement. That's the change in position divided by a change in time, or I can say time interval. Okay, displacement divided by a time interval. And that would give me only the average speed. So if an object was changing its direction, moving to the left and moving to the right, then the average speed would not necessarily be the same thing as the speed. And I'll show you what we mean by that in a moment. So that's velocity. What are the units? Well, for the units, we can actually look at what the units are for displacement. The unit for displacement is meter. The unit for a time interval, time is measured in hours, days, years. In physics, time is measured in seconds. So meters divided by seconds is the unit. So we would say the unit is going to be meters per second. So let's do an example. Example 1, a stationary object. So I'm going to show you guys this box and currently its speed, its velocity. Its velocity in the x direction is 0.0 meters per second. So let's see what that looks like. Okay, I let the time run. And from time equals, where's the time? From time equals 14.7 seconds all the way to time equals 20.52 seconds, the position was the same number. Let's figure out what was that position. So we can say at the time equal to, the beginning of this was 14.68. So when the time was 14.68 seconds, the position, so what should we call that? Let's call this A, time A. So this will be position A. Position A, let's see, let's count it up. It says here that the position, which is on my vertical axis here, the position is on the vertical axis, up and down, the y-axis. Y equals 12.64. Let's see if that's right. So I see 12 is here, 12.1, 12.2, 12.3, 0.4, 0.5, 0.6, and almost halfway between 0.6 and 0.7. So yeah, 12.64 seems right. So the position is a vector quantity, 12.64 meters to the right of the origin. And then at another time, we'll call it time B. That was a later time. Let's look at the end. That time is 20.52 seconds. What was the position at that time? Well, it's right here. The position at 20.52 seconds was 12.64. XB equals positive to the right of the origin, 12.64 meters. Alright, so it should be pretty clear that if we do the delta x calculation for displacement, the delta x from A to B was, I'll do with the letters first, xb minus xa, the equation for displacement, later position minus earlier position. So 12.64 meters minus 12.64 meters, that's 0 meters. Okay, so the displacement was 0 meters throughout this. So the velocity would be the displacement divided by time. So the velocity from A to B, the average velocity, and this would be average, so I'm getting a lot of letters here. The average velocity from A to B would equal the delta x from A to B. These are subscripts, so delta x would be the symbol, and then I'm having a little ab next to it. This is a subscript, which means it's a description of which delta x am I talking about, because you can have multiple positions, right? There were two positions here, xa and xb. So this A is a smaller letter that is lower and to the right of the main symbol, which shows it's a subscript. Okay, I just wanted to clarify that. move that over here. So let's get the pencil back. I'll write subscript. Okay, so let's go back to, which screen did I have? Did I have this screen? Yep. So the delta t, so 0 meters divided by, what's 20.52 seconds minus 14.68 seconds? 5.84 seconds? That was the difference between 12.52 minus 14.68. That's the difference in time, right? The amount of time between the two. Oops. When I do 0 divided by 5.84, I get 0 meters per second. Can I put this up here? I'm going to slide that up there so it doesn't interfere. Okay, that was example 1. Let's do another example. Well, let's not have a stationary object anymore. For a stationary object, the velocity was 0 meters per second. We should talk about speed before we move on. Speed is how fast along the path. So things can speed up and slow down, but speed is how fast right now. Or if I talk about the average speed, it would be what was the speed overall if you averaged all of the different speeds that happened at every moment. So what is speed? Well, the symbol we use is v, just like velocity. So velocity and speed are very similar, but there's no arrow over top for speed. So the direction is not communicated. Direction of travel not communicated. Since the direction is not communicated, this is a scalar quantity, which means we put no arrow over top of it. All right. So let's have a different example. I'm going to call this example number 2. Constant positive velocity. Let's give this thing a velocity of positive 0.4 meters per second. Hit enter. All right, now let's let time run through. We were at a time of 20.52 seconds. Let's continue. So now the object is moving to the right. Let's let this run for a little while. Okay, that's good enough. So now we have a new time, and that new time is 28.18 seconds. All right, and we had 20.52 seconds before. And the position now, let's actually read the position. This is a lab skill, being able to read a scale. 15 meters is here. 15.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Ooh, just after 0.7. Maybe 0.71. What do they say it is? 0.704. So I'm going to say 15.70 meters. 15.70 meters. Let's keep that on the screen so I can see the time. Okay, so now we're looking at a new position. Let's call this position, I've used A and B, so let's call this C. Position C will equal, position C is 15.704 meters. It's Y on the graph because the vertical axis has position on it. So even though it's the variable x, it's listed as y on in this program because it's the vertical axis. We put the position on the vertical axis all the time because vertical axis is the output of a function. All right, so the position C was 15.704, so I'll just say 70 meters. And that was at a time of time C, we'll call it. Time is not a vector quantity. Time is a scalar quantity. And the time was 28.18 seconds. Okay. How many seconds was that after the previous one? Well, let's just write, let's take our information from before. Yeah, I didn't make it easy on myself. Let's just copy and paste it. Alright, and we'll take out all this extra garbage. There we go. And it looks like I just changed my naming methods, so let's make that consistent. So I'm just going to move this over here. Okay. Oops, let's put a little plus there. All right, so now we're looking at time B versus time C. All right, let's use another color. Let's use blue. So let's look at B to C. And for this we're going to do what was the average velocity? From B to C, so I guess I have to use B, C, and then the average velocity. And let's calculate the speed, B, C, average. Okay. And that's good. So how will we calculate this? We're going to do, for velocity, we're going to say displacement, so delta x from B to C divided by the change in time from B to C. So really that's xc minus xb, the later time the later position minus the earlier position. Let's put an arrow over displacement. And we've got time C minus time B. Okay, so now we have to subtract. So really we're looking at 15.7 meters minus 12.64 meters. Dividing by the times, this is the difference in the times, 28.18 seconds minus 20.52 seconds. Okay. Oh, I'm going to need to move this down. There we go. So what do I have on top? I've got 15 point, okay, I can do that calculation. I don't need to. All right. 15.7 minus 12.64, 3.06. 3.06 meters, and that's a positive number. So to the right. Dividing by the quantity. Okay, let's do 28.18 minus 20.5452. And 7.66 seconds was the time interval. All right. Great. .06 divided by 7.66, 0.399477. Wait a second. I shouldn't have this many decimals. This is kind of ridiculous. Meters per second. How should I report this? What would be responsible of me to write how many decimals? Well, here I had 4 significant figures. I go to 2 decimals. If you don't remember your rules for sig figs, you're gonna have to look them up. I've got 4 sig figs. Okay, here I've got 4 sig figs. So I guess I can report to 4 sig figs. There's an argument that says maybe I should only report to 2 decimal places. I think I'm going to report to 4 sig figs. So 0. Alright, so I've got a 3, a 9, and a 4. So that would become a 5. 3995 meters per second. That's about 0.4 meters per second. Okay, that's close to 0.4 meters per second. It's good to remember to think about what things mean. Like, what does 0.3995 mean? It's practically 0.4. It's so close to 0.4. All right. This is a vector quantity, velocity, so I have to include what is the direction. So because I got a positive number, that means this is to the right. So you have to include that for velocity. For speed, you don't include it. Okay. Was the object changing direction during this time interval from 20.52 seconds to 28.18 seconds? No, the direction was not changing. So I want to just say, all right, 0.3995 meters per second. And I don't include anything. That was the speed. All right. So that was from this time point, 20.52 seconds, to this point in time, 28.18 seconds. There was constant velocity. The velocity was not changing. The velocity is actually the slope. So take a look at where it says dy divided by dx on this dy divided by dx on this graph. It says 0.400 meters per second. Dy divided by dx means the slope. So the slope of this graph was 0.400 meters per second, which is very close to what I have, 0.3995. If the 5 were to round that 9 up, then this would be 0.400 meters per second if I was using 3 decimals. Because AlgoDo, the program that I'm using here, the simulation program, uses 3 decimals for its velocities and for its positions, then it went to 0.400 instead of 0.3995. So that makes a lot of sense. It's so very close, right? It's very, very close. Close enough that we would call it the same. I want to look at not just this time interval, this after 20.52 seconds. I want to look at the time interval from the whole beginning to the end. So the time interval from 14.68 seconds all the way to 28.18 seconds. Because here the slope or the velocity was 0 meters per second for the first little bit. And then after that, from 20.52 seconds onward, the speed was 0.4 meters per second. So what would we get if we did our equation for velocity, which is actually average velocity? Well, we need some data points. So now we're going to be looking at 2 points in time. We're going to be looking at 14.68 seconds and 28.18 seconds. Now I have that information. Here is C. So let's put that down here. So let's write, we're going to call this comparing time A to time C, because we just did from time A to time B. We did from time B to time C, but let's do from time A all the way to time C. I needed information for time A, and that's right up here. Oh gosh. Select using freeform. Let's do that. Let's select that. Pow. Control C, Control V. All right. I seem to write uphill. Okay, so now I have my 2 points. At time A, 14.68 seconds, the position was 12.64 meters to the right of the origin. And at time C, which was 28.18 seconds, the position was positive 15.7 meters to the right of the origin. All right, so between these 2 points in time, let's find the average velocity. So V AC average. Okay. This would be XC minus XA, those two positions. That's the displacement, a difference in position, a change in position. And time C minus time A. So that's, I'm going to write it all out, 15.70 meters minus 12.64 meters. And I'm dividing by the time, 28.18 seconds minus 14.68 seconds. Let's do that calculation in our calculator. I'm going to do it all in one step, but I'm going to need parentheses. So something about calculators. They're really smart, except they're not. So what you have to put in a calculator in order to do this in one step, you have to put in 15.7. You have to open parentheses first. Then you put in 15.7 minus 12.64. And then you close parentheses for the top. And then you do the divide symbol, which on your calculator might look like a horizontal line with two dashes, or it might just be a slash. And then you need parentheses on the bottom. or else it will like do the calculation with the first number and then not the second number. I think with minus it doesn't matter so much, but when you have a product of things on the bottom, then it becomes a problem. When you have a product on the bottom, a product in the denominator, calculators do not know how to handle that without parentheses. So you need to make sure that you put that in. Okay, so let's do this all in one step. 15.7 minus 12.64, close parentheses, divide by, or slash, open parentheses, don't forget that, 28.18 minus 14.68, close parentheses, enter. So I got, let me just make sure that I'm showing the camera. .5566. No, maybe that's not a 5. Maybe that's a 2. It's backwards. 0.2266666666. Okay, so what am I going to do with that? I think I need to go to 2 decimals or to 4 significant figures. Yeah, 4 significant figures. So 0.2267 meters per second. And what would algo do? It goes to 3 decimals, so 0.227 is what they would have for the average velocity. All right, let's compare. So what was the velocity originally? So like velocity during interval A, let's say velocity from, oh, and I need, since this is a velocity, I need to put to the right. In the positive x direction. You have to include a direction when you're talking about velocity. So AB, the velocity during the interval, if I don't even put A average, the velocity, the instantaneous velocity at all of these points, look at the dy dx, 0 meters per second. The velocity was a constant. So all the instantaneous velocities from time 14.68 all the way up to 20.52, the velocity was a constant 0 meters per second. So VAB, I'm going to write the speed, was 0 meters per second. No, I'll make it velocity was 0 meters per second, and I don't need to put a direction, so there's no direction. But if I could write to the right, that'd be fine. And then I had a velocity BC, and that was 0. Let's say 400, because AlgoDo said it was, meters per second to the right from time B to time C. So during that time interval, I had a speed of 0.4 meters per second. But if I take from the beginning to the end, the average velocity, and for that I'm going to do a screenshot of this. I'm going to drop. Let's see how I can do this. I can open that. I can paste. And I can crop. So here's that graph. Yeah, that'll work. So there's that graph. So really, what did we do? What velocity did we find? We found the velocity from here to there. Oops. So this was V. The velocity throughout here was, let me make a little arrow, velocity AB. was equal to 0 meters per second throughout the entire thing. That was the slope of this graph, this section of the graph. And then in this second section, let's use a different color. In the second section here, we had a VBC, and that was equal to 0.400 meters per second. And where's that? That's the slope. So velocity is the slope. On the vertical axis here, this vertical axis, that's position. So we've got position x, which is measured in meters. Okay? And on the horizontal axis, there was time, and the time was measured in seconds. So the slope of this graph, rise divided by run, would be meters, that's the rise, divided by seconds, that's the run. So if we were to do a rise over run, the rise would be in meters, the run would be in seconds. So the slope of this graph would equal meters divided by seconds. So the slope is the velocity. The slope of this graph, position versus time, the slope of a position versus time graph is velocity. Now, what is this red line? This red line is V average from A all the way to C. V average from A to C. I've been using a different naming convention. V from A to C, average. This is an average velocity. I'll use no arrow so I can say it's speed. That way I don't have to write the direction. And I got 0.2267 meters per second. Alright, so I had a first velocity and a second velocity, but the average velocity only considers 2 points, from the beginning to the end, and it draws a straight line. The rise over run of that straight line would be the speed, the average speed, for that time interval. Alright, I'm going to show you one more thing. How far into the recording? 38 minutes. We're going to stop there. Alright, I hope that was helpful. Email me with your questions. This will unlock for you more Khan Academy content so that you can test your knowledge. Alright, thank you guys. Take care.